Hey, welcome back to chemistry. I want to talk with you for just a few minutes about pressure and unit conversions and get you a little bit familiar with how we look at those things and how we'll be able to get from an awkward unit to one that we need for chemistry. Briefly, pressure is defined as a physics term as the amount of force per area that's being experienced. And so we'll talk about atmospheric pressure, and this is going to be the weight of this giant column of air that's above us, so going all the way up through the stratosphere. All of that air is being attracted to the center of the Earth by gravity, and that is being pushing down on us, just like when you dive underwater. You'll feel the weight of the water above you as you go deeper, that we in fact live in a pressurized area where we have the weight of the air above us is pushing down. So we live in a pressurized area, and what we're often trying to do is figure out how much pressure is there. So an old but effective way to do that is really a barometer. And a simple barometer is really just taking a tube that's open at one end, filling it up with mercury, and then tipping it carefully upside down into a pool of mercury. And that mercury wants to sort of fall, so gravity inside that column is pulling that mercury down. But there's also the atmospheric pressure on the outside, so the weight of all that air above it is pushing down on this pool of open mercury, and that reaches some balance point. And this is how we measure. This is the exact measurement for millimeters of mercury as a pressure. So you may have heard like a hurricane that's being identified. It say it has a low pressure and there's 750 millimeters of mercury. Well, this is exactly the measure that they're talking about. That if you take a tall column of mercury and you measure it, you will find what measures about that many, 750 millimeters high. So a barometer is one way of measuring sort of the absolute pressure. So if there was no atmosphere, that there would be no difference between the vacuum on the inside of the tube and the vacuum on the outside, and they would all come together as one level. There are other measures that we're going to use. So millimeters of mercury is one that's commonly used in atmospheric sciences. In chemistry, we're going to use ATMs a lot. So an ATM is a convenient measure for us because we live at sea level under normal conditions. We define that as one ATM. So it's a simpler calculation for us to do, and allows us to be able to use simpler math to be able to answer chemistry terms. But we need to get between them. There's a third one that we'll use, which is kilopascals, and this is the conversion to the physics unit. So the newtons per square meter is a pascal. So 1 atmosphere is going to be the equivalent to 101,000 pascals, or 101 kilopascals. We'll come across this in everyday life, so if you ever have to fill up your tires with air, that you may know that you put it up to about 30 psi, so pounds per square inch, which is a British unit, and 1 atmosphere is about equal to 14.7 psi, so when you fill up your tires, you're adding an additional 2 ATMs of pressure inside the tires compared to the outside. So that's another unit. We're not going to use that too much in this class. Well, there are a number of ways that we can measure pressure in chemical reactions. So one is just to know what pressure has happened. If it's an open reaction, something that we're doing in the open atmosphere, which is often the case, that we can use this sort of barometer to try to figure out what the pressure is. But a lot of times we may want to know what the pressure of a reaction that's generating is. And so in that case, we can use this device that's called a manometer. And this is a closed system, so notice that I have this purple gas, so maybe it's a reaction that I'm doing on the inside. And I've sealed that with this column of mercury, and I can tell the difference in the pressure that the gas is pushing from the inside, compare that to the outside from the atmosphere on the right-hand side. And that difference in height will tell me the difference in pressure between the inside and the outside. So it gives me a way to determine the pressure that's there. So we'll use pressure in a couple of different ways. We're going to use it primarily when we're trying to look at gases and understand the behavior of gases, because expanding and contracting of gases is part of essentially a reaction, and that's something we'll worry about making. So we're going to worry a lot about standard pressure, and standard pressure is where we're at sea level on a calm day. So the standard pressure is 1 ATM. That's also equal to 760 torr, or 760 millimeters of mercury, or it's equal to 101.325 thousand pascals. So what I'm going to ask you to do is be able to get between these. So let me remind you briefly about unit conversions, and then that's going to be all that you need to know for right now. So let me switch gears. And there you go. Here it is. Okay. So unit conversion. So remember how we do this. So we have some conversion factor. I know that 1 ATM is equal to, I don't know, 760 millimeters of mercury. So this is a conversion factor. Remember, I can make two fractions out of this. So I can say 1 ATM divided by 760 millimeters of mercury. This is equal to, numerically equal to 1. Or I can make my 760 millimeters of mercury. I can divide that by 1.0 ATM. So these are two fractions which are both mathematically valid fractions. And now when I have a question, I can use one of these two fractions to convert from one thing to something else. So suppose I start with, I don't know, 0.35 ATMs, and I want to know how many millimeters of mercury that represents. So remember how I go about this. So I'm going to draw crosshairs, and I'm going to pick one of these two fractions, and I'm going to worry about lining up the ATMs on the bottom here. So looking at these two fractions, this left one is the one that has the ATMs on the bottom. So I'll use that fraction to do my conversion. So notice my ATMs will now cancel, just my units of ATM will cancel. And now I can get out my calculator and multiply 0.35 times 760 and divide by 1.0. And I'll get to my answer. I don't know, whatever that is. It's going to be in millimeters of mercury. Again, so we'll worry about getting between ATMs and millimeters of mercury. The other one that we'll worry about is kilopascals. So 1.0 ATM is also equal to 101.3 kilopascals, 1,000 pascals. So these are the conversions that we'll worry about. There are other ones, and there are a bunch of different measures that we can use. So you'll come across some interesting measures for pressure that are used in specific domains. But we're just going to worry about these three ATMs, millimeters of mercury, and kilopascals. Anyway, I hope that's helpful, and we'll talk to you soon. Bye.